Guys, good to see you today. Mr. Hussey here, 8th grade math. This is Wednesday's lesson. It's a continuation, more practice on graphing and substitution methods. Okay, so your job today is going to be to do numbers 5 both ways, 6 both graphing and substitution, 7 and 8. Okay, and once again, if you don't have graph paper, you can use white line or just white paper and make your little XY chart, and then just do your best to count up even notches and make the graphs hit at least in the right at least in the right quadrant 1, 2, 3, or 4. Okay, so you're going to show me a general picture of that if you and do your best. If you don't have the graph paper, you can't print this out. Okay, so the graphing method, first thing we need to do is we need to get these equations here into the y equals mx plus b form, which is what we call our slope intercept form, okay, where m is the slope and b is the y intercept, or like I call it, where it crosses the y axis. Okay, so on this first one, what we have to do is we have to take that equation that we're given, okay, and if you look at the equal sign, you can see that on the left of the equal sign, we have a y, which is good because up here in the form we want it to be, on the left of the equal sign, there's a y. So that y can stay put. The thing we need to get on the right of the equal sign, if you look at this equal sign, is the something x, or the slope x, or the mx. Okay, so in this case, we need to get these negative 4x's over there. So in order to do that, I'm going to plus 4x's. This side will cross off, plus 4x's to each side of the equal sign, obviously. My y will drop down, so I'm just going to shift it this way just a little bit so I have room over here. So y equals, and then this would be 4x minus 3. Okay, and once again, I keep talking about this, but that the plus 4x and the minus 3, they don't mesh. Like, you can't add 4x's to just 3. So they're two separate entities. So that plus 4x shoots to the front because we want it in the front. And then the minus 3 shoots to the back because we want it back there. Okay, and it's both on the right side of the equal sign, so we can do that. So now we know what one of our equations is, y equals 4x minus 3. Okay, so the minus 3 we plot by going 1, 2, 3. Negative 3 on the y-axis, right? So that's where the minus 3 comes from. And then the 4 is our slope. Okay, and remember that our slope means our rise over our run. So if we have a slope of 4, that's like saying, okay, what number over 1 would that be? Well, obviously be 4 over 1, because 4 over 1 is 4. So every time we locate that first point, every time we run once to the right, so from here to here, we have to rise 1, 2, 3, 4, put a dot, and it's that same ratio. So every time you run one, we run one, rise 1, 2, 3, 4, put a dot, run one, rise 1, 2, 3, 4, put a dot. Okay, and then back the other direction, it's just the opposite, because if you ran 1 negative and then dropped 4 negative, 1, 2, 3, 4, that'd be like negative 4 over negative 1, which is still 4 over 1. Okay, so that's why it makes sense going backwards in that direction too. It's not just some magic trick that doesn't make sense. Okay, so now we're going to go ahead here. We're going to draw ourselves a straight line. Okay. Like I said, if you have separate paper, just do your best on that. Make it as clear as you can. Okay, and then the other, we got one line. This line is y equals 4x minus 3. Okay, you can put arrows here if you want, showing that that line will keep going. So this line is 4x minus 3. Now, what happens when we have a line that says x equals 1? Do we need to shift it into this equation? Well, we can't really, but what you need to think of when x equals 1 is x is always 1. Okay. What I mean by that is that if you make a little xy chart, then x is 1 when y is, say, like negative 2. X is 1 when y is 0. and x is 1 when y is any number that you can think. So I'll say 2. I like to think of like a negative number, a 0, and a positive number. Okay, so x is always 1. It's 1 in every situation, every circumstance. So when x is 1, y is negative 2. When x is 1, y is 0. And when x is 1, y is 2. Okay. Also, if we want to keep going, when x is 1, y is 7. When x is 1, y is negative 7. So if you start plotting these points, you can see that it's going to form a vertical line here at x equals 1, or 1 spot over on the x-axis. So now you have your other line, okay, and this would be your line x equals negative 1. So now I have my two lines, and the way we find the solution is where those two lines meet, okay? And in this circumstance, it's really hard to see. In fact, I got confused myself. I thought it was here, but then I checked and it's a 1 to 1, 2, 3, 4 ratio, so it must cross right there. So I'm thinking my answer here is 1, 1. But let me just check so I'm going to put my answer is 1, 1 for the graphing method. Location 1, 1 is where the lines meet. When x is 1, y is 1, that's where the lines meet, and that would be my solution. Now let's go ahead over here to the substitution method. Okay, the substitution method, we have our two equations. Our first one, which we already did the hard work here, and we already made it into y equals mx plus b form. So we'll write that down, which is right here. We did that, okay? And then our second one, x equals negative 1. Okay, and what you do on this type of problem, it's a little different. But this actually makes your life easier, because in this case, there's not two y's where you set like this equal to this one. So you just take this and plug it in there, and then you have y equals 4 times negative 1 minus 3, or y equals negative 4 minus 3, or y equals negative 7. Okay, and then what's going to happen is I'm going to take that x is negative 1. Shoot, all right, I'm going to have to come back to that. So leave all that work. We're going to leave that, set that aside for a minute, and go to the next one. We'll definitely get the next one, and we'll come back to this and see what I did wrong, because I'm getting myself confused here. All right. Now, obviously, on a quiz or a test, I would give you help on something like this. If I am confusing you, okay, especially with this situation going on there. But leave that work. You'll get credit for your work, and we'll come back to that and see what I was doing wrong. I made a mistake somewhere. I don't want to waste the time finding it right now, although I'll come back to it. All right, so let's go ahead and take a look at number 6 here. Now, number 6, we have to go ahead and change both of these because they're both in what we call standard form. Ax plus by equals c. Ax plus by equals c. So we have to change both of them into this slope-intercept form in order to get started, okay? So let's go ahead and start with the first one. Okay, and like I said, we got the y on the left side of the equal sign, so that's good. So we got to get these three x's over here. So we're going to get y equals negative 3x plus 6. So the negative 3x just shoots here because we want it at the beginning of the right-hand side of the equal sign. And then the plus b is going to be, in this case, plus 6 because there's no symbol in front of there, so that's a plus. Okay, so this is our first one. Okay, and then our second one, we would take 4x plus 5y equals negative 25. So my y's are okay over here. So let's subtract 4 x's and get it over here. So now we have 5y equals negative 4x minus 25, because the negative 4x will go kind of shoot in the front here, the negative 25 over here. Now this gets a little tricky. We'll divide each side by 5, because we need y, we don't need 5y. So we'll divide both sides by 5, and we get y equals, the way they want you to write this is negative 4/5 x minus 5. So this will be negative 4/5 comes from here, and the x matches up with that. And then negative 25 divided by 5 is a minus 5. So here's our second equation, okay? So on the graph side of things, this one crosses at plus 6. Y equals blah, 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 plus 6. So 1, 2, 3, 4, 5, 6. So there's our dot. And then the negative 3x is our rise over our run. So if we were to run 1, okay, I always like to make that a 1, then we would rise negative 3, because that produces a negative 3, or a slope of negative 3, which they're telling us right here. So every time I run 1, I drop 1, 2, 3. I run 1, I drop 1, 2, 3. It's a 1 to 3 ratio, 1 over, 3 down, and make sure you don't get confused with your rise and your run. Make sure you don't do it 3 over and 1 down, okay? All right, now over here, this one here is blah, 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 minus 5. I'll draw this line in a minute, okay? So gonna go down 1, 2, 3, 4, 5, put a dot there, okay, for that minus 5. And then our slope here, if you look carefully, actually I should bring it over here, is negative 4 over 5. So this would be our rise, this would be our run. So that's how the fractions are almost easier in a way, because they're already kind of set up for you, rise over run. So when we run 5, 1, 2, 3, 4, 5, then we have to drop 4. 1, 2, 3, 4. Okay? So this spot here is going to be where the lines cross, because as you can see, if I draw this first line, okay, this first one will be 1 over and 3 down. I just didn't keep going that far. I should have kept going. This one would be 5 over, 1, 2, 3, 4, 5, and then 4 down. 1, 2, 3, 4. So if I go 5 over this way, 1, 2, 3, 4, 5, then it should be 4 up. 1, 2, 3, 4. Okay? Should go in the reverse direction at the same ratio. So now when these two lines go ahead and meet, our answer for this one is 1, 2, 3, 4, 5, and negative 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 5, negative 9 is our answer here on this side. Now, if we did it correctly, we should get the same answer over here. So let's check the answer over here. To find the substitution method, okay, this one was a little different, and I made a mistake on that, so I'm going to have to come back to that. But usually, when you do the substitution method, you have y equals this, and then you have y equals this. So you know if this is equal to y and this is equal to y, then they're both equal to each other. So I just take this first one, negative 3x plus 6, and set it equal to negative 4/5 x minus 5. And so I just set this equation equal to this equation, okay? And then there's a whole bunch of things we can do here. Let's go ahead start by adding 5 to both sides. Okay, so we'll get negative 3x plus 11 is equal to 4/5, negative 4/5 x, okay? And then one thing we can do here is we can times both sides to get rid of like a divided by 5 here. We can times both sides by 5. So if you times this side by 5 and this side by 5, what happens over here is pretty easy. 5 times negative 3x is negative 15x, plus, using our distributive property, because this number distributes there and then it distributes here. 5 times 11 is 55. Okay. Now what happens over here, like I said before, isn't the magic trick, is it's just negative 4x. Okay, because these 5s cross off. But what's really happening is when we times by 5, we're really timesing by 5 over 1, which gives us on the top, negative 4 times 5 is negative 20. So it really gives you negative 20 on the top. And a 5 times a 1 is a 5 on the bottom. So I'll just write them in. It's almost like up here you get a negative 20. And then down here you get a 5. And then negative 20, I know that's hard to see, but negative 20 divided by 5 is negative 4x. So you got to keep that x, okay? Or you can cross reduce. You can like cross this one off and this one off. This 5 off and this 5 off and get 1s, okay? But there's something going on behind there where that's why you can cross it off and get a negative 4x, okay? Now our next step here would be to add 15x to both sides. All right, and now you get 55 is equal to 11x. Because negative 4, if the temperature is negative 4, you go up 15 degrees. Now you're at positive 11. Then you just divide both sides by 11. And this will give you x equals 5. Okay. So our first number, this is a lot of work, but our first number here in our xy number is 5. Okay, so our first part of our answer is 5. And then if you take your 5 and you plug it back up into one of these two equations, one of these two original equations, if you put the 5 that you just got here into either here or here, then you'll get what y is. So I'm going to put it into this one we changed to this, right? So I'm going to put it in here. So if I take that 5 and put it in here, it's going to be negative 3 times 5, which is negative 15. Plus that 6 right there that we have to bring down. And negative 15 plus 6 is negative 9. So in the case that x is 5, y is negative 9, and then we did a nice job. We got them both the same there, so we know we did a nice job. Let me just real quick, before you guys leave, let me just check that first one. Okay. So it looks like I did this side right. When we got to this first one, the answer was negative 1, negative 7. Okay, because when I got that negative 1 for negative 1 was already kind of given to us for x. And when we plugged that in, we got negative 7. And then I'm like, oh, shoot, what did I do? Because I could see that this one didn't match up with the first one. So I knew I did something wrong. So it looks like I did something wrong on the first one. Let's just check real quick if we can see what I did wrong. And I'm still having trouble figuring that out. So I don't want to waste your time. So do the best. Maybe you can figure that out. Maybe you can figure out what I did wrong over here. But go ahead, show your work. Obviously, you're graded on your effort. Okay. So, but go ahead, make sure you're getting this one right. Give a shot on this one, see if you can get it right. I'll take a look at it later and see what I did wrong. And then do 7 and 8. Okay, now, if that takes you 40 to 45 minutes and you're doing a legit hard-working job, then you can stop. If for some reason, like you're halfway through 8 and you didn't get to finish, you can stop and shoot me an email, tell me you worked hard, and I'll give you full credit for working hard today. Okay. All right, guys. Thanks a lot. Thanks for your time. Take care. Have a nice day.